right, everybody say hi, Luke and Claire.
Hi.
And anybody else watching this video if they're watching. The homework assignment, page 20, 12 through 48 evens. This is another short-ish assignment. I'm going to kind of go a little fast because my computer is going to die. So hopefully we can get through this before it does that. Because I'm not allowed to use a cord, and it drains the battery faster than it lets me record. Anyway, all right. 1, 2 is line segments and distance, okay? Most of this is pretty straightforward, and then at the end we get to the distance formula, and that's something that we do a lot in this class. So we'll go through that, and that's something that I really, really, really want you to remember how to do, okay? Unlike a line segment, unlike a line goes forever in both directions, but unlike a line segment has 2 endpoints, okay? And line segments can be measured. Lines cannot be measured, line segments can. So here in example 1, they have the first one that we're doing, and we're measuring in centimeters. The second one in part B is measuring in inches, and we're going to try to see what the length of each one of these is. So in part A, how long would you say maybe that is, ish? It's not quite 4. Like 3.5 would maybe be there, and 3 3/4 maybe?
Yeah.
Right?
Yeah.
So we could go 3 3/4. It's a little less than that. But I think that's what we went with this morning was 3.75 centimeters-ish. It's going to be pretty darn close, okay? In part B, we're measuring in inches, and we're going from C to D. So here's 1 inch, here's 2 inches. This middle one right here would be 1 1/2 inches, right? What is this D at? 1 1/4, right? So this would be 1 1/4. What would like this line right here be at? 1/8. And then this line right here in the purple would be a 16th, right? Okay, so that's how we would measure those. So this is going to be 1 1/4 inches long. That is that line segment for CD. Happy with that? Okay, this next concept is called betweenness of points, all right? And basically it's saying if you have 3 points on a line, the length of this one, let's say that that is 6, and the length of this one, let's say that that is 4, will give us the length of the entire one, which would be 10, right? It's just like adding 2 segments together to give me a total segment, okay? Now they're going to have segments of that are missing, and we're just going to find the one that's missing, okay? So example 2, it says find AB. So we don't know the length of this chunk. We know that the total is, there's a decimal there. I don't know if you can see that. 13.2 is the total. 5.8 is what BC is. How would you find what AB is? Minus 5.8, exactly. And then that is like 7.4. And that's in meters, and that's my answer, yeah? It's almost too easy. But then they get us to something on part B where we have variables involved, right? Okay? And then it's maybe a touch harder, but not too bad. We still are dealing with the concept that, and if it helps you to think about it in terms of this, please do. We have 2 pieces that we're adding together. So 2 chunks added together make the total length of the third chunk. We have 2 pieces added together, make the third piece. And then we're going to just fill in the blanks. So what 2 things are we adding together? 3A is a small one. 14 is the other chunk, and the entire length is 5A minus 4. 5A minus 4. So then we just solve, right? What do you want to move?
4
Let's add the 4. Sure. And can we subtract 3A at the same time? Minus 3A. So 14 plus 4 is 18. 5A minus 3A is 2A. And if we divide by 2, A will be 9. I'm going to try to make my A's not look like 9s, except, yeah, I know, my A's and 9s look the same. A is 9, except they want more than just A. Be careful when you're doing your homework assignment because they will ask for something else besides just the variable. Find the value of A and the value of XY. XY is this length right here, and XY is 3 times A, which is 27. So they want both of those answers, 9 and 27. Does that make sense? Okay. I know on your homework assignment they give you something and they don't draw out the picture of it. They just say X is between Y and Z, and then they say XY equals something, and YZ equals something, and XZ equals something, right? Draw a picture of what it looks like, okay? If X is between Y and Z, you have Y over here, you have Z over here, and X is somewhere between those, right? Doesn't necessarily mean that that it's in the middle, right? Okay. But if they give you something like that, draw a picture and then label each one as it's supposed to be. So I think that's like 18, 20, and 22 are like that. They don't give you the picture, just draw the picture based on where everything is located, okay? We're gonna skip example 3 because it involves a compass, and I'm not gonna do that don't put a line through it necessarily. But anyway, we're gonna skip over that. Libby's like, crap. We're going to skip over that because I can't do a construction on a video. And so maybe we'll do that with a compass here in a second when I stop recording. Example 4, find the distance of BE. And they give us a number line, okay? Finding the distance. From B is at -6, E is at 2. And if I'm trying to find the distance between -6 and 2, I don't necessarily want to count. So what we can do is finding the distance is like finding the difference. And finding the difference means that we're going to subtract, right? So I could take 2. I usually take the second one minus the first one. So 2 minus a -6. And that's like 2 plus 6. So that is 8. So they are 8 units apart. Now, let's say that you subtract them in the other order. Let's say you take -6 and you subtract 2, right? That will give you -8, but keep in mind, distance can never be negative. So whatever number you get, you have to always take the absolute value. Do you remember absolute value? Absolute value means turning everything positive, and that's going to give you 8 also, okay? So it doesn't matter what order you subtract them in, just know that your number will always be positive. Make sense? Okay, B says determine whether CA and ED are congruent. And congruent means, are they the same length? CA and ED. So C and A is at -7, C is at -4. So let's do it this way. Let's do it in our heads. How far apart is -7 and -4? 3, right? So CA is going to be 3 units. Okay, ED. How far apart is -2 and +2? 4 units, right? Okay, are they congruent? No. They would have to be exactly the same length in order to be congruent. Make sense? Good? Okay, the last thing is the distance formula. And I hope I'm doing okay on battery here. 7%. Okay. Distance formula. All right, this is huge. This is the thing that I want you to make sure that you remember because we will use this quite a bit, okay? All right, distance formula. I'm going to give you an example off to the side over here and show you how this distance formula kind of operates, okay? So let's say I have a line segment, and I'll make this kind of easy. Let's say I have a line segment starting at 0, 0, and I'm going to the point 4, 3 up here, okay? And I want to know the distance or the length of that line, okay? And it's at a slant, so it's going to not be 4 and it's not going to be 3. It's going to be some other unit, and I have to figure out how long that is. So what I'm going to do is I'm going to make him into a right triangle, okay? And this is going to look kind of funny. I make him into a right triangle, and I say, how long is like this side of that triangle going to be? Like, how long would that be? If you're going from 0, 0 to 4, 3, how long would that bottom side of that triangle be? 4, right? You're going to the right 4 units. That's the x coordinate, right? And so what you did to figure out that that was 4, you did it in your head. You took 4 minus 0, right? That's the distance between those 2 points. You did 4 minus 0. Now, let's see what the distance of the right side is. So what would that distance be? 3. And you took, to figure that out, in your head, you did 3 minus 0. That's kind of what that is, right? Okay? Now, if I'm trying to figure out the length of this guy, and that's a right triangle, what can I do? The Pythagorean theorem, a squared plus b squared equals c squared. So we have 4 squared plus 3 squared equals c squared. 4 squared is 16 plus 9, and we have 25 equals c squared, and the square root of that gives me 5. So the length of that segment is 5. Okay, does that make sense? When you're doing the distance, you are exactly doing the Pythagorean theorem. So the distance formula is this guy right here. And this is literally set up as a squared. This is a squared plus b squared. Don't cross these out, actually. A squared plus b squared equals c squared, except they don't have c squared, right? Where did the square go on the d? They made it a square root instead of putting the square here, right? They got rid of that. So they took the square root of a squared plus b squared. Well, over here, to figure out what a was, didn't you take the 2 and you subtracted them, right? To figure out what a was, you took the x coordinates and you subtracted them. You took x2 minus x1, right? And to figure out what the b was, you subtracted the y coordinates. You took 3 minus 0, right? That's what you did for b. So this distance formula is based entirely off of the Pythagorean theorem, okay? We're going to do the distance formula the way that it's written, and then I'm going to show you how to do a shortcut, okay? So the first one, find the distance between each pair of points. We do the square root of, and I'm going to do my 2 bubbles, and you're adding them together, doing the 2 bubbles, okay? And the formula says x2 minus x1. What's your second x? Which one is x2? 5 minus a negative 4. And then we would do for the y's, we would do this second y is negative 1 minus a negative 6, okay? And really those double negatives will become positives, right? So 5 plus 4 is 9, and we have 9 squared, which is 81. Plus negative 1 plus 6 is 5, and 5 squared is 25. So that is the square root of like 106, which is 10.3, I think, is what we ended up getting as a decimal. Okay, does that make sense? All right, now, I can do less work than that because I can do some of that in my head, right? The really nice thing about the distance formula is that when you subtract the x coordinates, it doesn't matter whether it's positive or negative because the square is going to end up changing it to be positive no matter what, right? Okay, so here's the deal. All you have to do is look at the x coordinates, and I say to myself, looking at 2 and looking at negative 3, how far apart, like on a number line, would 2 and negative 3 be? How far apart would they be? From 2 to negative 3. There'll be 5 units apart. Now, maybe it's a negative 5, but we don't care because negative 5 squared is going to be the same as positive 5 squared. Does that make sense? It's going to be 25 no matter what, right? So we just kind of did a shortcut because we did some of that in our head, right? Now we look at the y coordinates from 4 to negative 2. So how far apart are 4 and negative 2 on a number line? 6. Maybe it's a negative 6, but we don't care because it's going to end up being positive. So we have 25 plus 36, which is the square root of 61, which is like 7 point, I don't know that answer.
7.81.
7.8 will go. Yep. Perfect. Okay, makes sense?
Yep.
Good? Okay, down here, I'm not going to read through the story problem, but we have Luke basically is 5 yards in, and he's on the 20-yard line. And then we have Xavier over here that's 60 yards in on the 20-yard line. No, 20 yards in on the 60-yard line. Whatever. Anyway, the reason why they put it as 60 instead of as 40, you guys see why?
Yeah.
Because like 50 is here and then they have 40s on either side. So they labeled the 40-yard line actually as 60 because, you know, it starts counting backwards then. Okay, so they want to know how long. How long is that pass? You're going from, that would be 40-yard pass, right? It's actually, pass would be if they were going straight from here to here. That would be 40 yards, right? But it's not going to be exactly 40 yards. We're going to use the distance formula to figure out how long it is exactly. All right, so the square root of something plus something, okay? And we're going to look at our x's and our y's, okay? So how far apart is 20 and 60? 40, so I put 40 in the bubble, right? How far apart is 5 and 20? 15, so I put 15 there, okay? And then I just do the math. 40 squared is like 1,600, I think,
Yeah.
plus 15 squared is like, I think, 225. And then I add those together, and that's like 1825, and I take the square root, and that is
5 square root of 73.
what's the decimal?
42.7.
42.7 yards, right? So they would call that on TV a 40-yard pass. It's actually almost 43 yards. They're jipping them 3 yards, right? They should get credit for all of it. Anyway, so that's what that. Do that because it makes it a lot faster and quicker, right? Okay. And I'm getting ready to die on my computer. Everybody say bye.
Bye.